Okay, that was 10 minutes. You get about 15 per question if you were to break them equally, and obviously some questions need longer than others. So I probably could have spent a little bit more time on this one. But we're going to go ahead and just talk about each section, and then we're going to look at the scoring guide or the rubric that accompanies this problem and see how what you wrote down or how that would have been scored by an AP reader as best we can guess. So the first question, to the nearest whole number, how many cars pass through the intersection over the 30-minute period? A lot of times I would continue to remind yourself of what our units are. The function that they gave us, f of t, is in cars per minute, as it said up in the problem, right? They said that it's defined as that function in cars per minute. So if I want to know cars, we would take the integral of that. We would need its antiderivative, right? So that's exactly what I would set up here. We're looking at the integral from 0 to 30 over that 30-minute period of our function. Now, here's a good thing to know. If they have at some point anywhere on that piece of paper defined the function as some letter, in this case f of t, I can put that here. I can put f of t because it is something that is defined on there. Okay? I can also just write the 82 plus 4 sine of t over 2. However, if I had put my problem like this, it would be incorrect. And I noticed this a lot on our quiz. I caught a lot of people, if you do not have the variable of integration, that is not a correct integral. So make sure that what you wrote down for that one has a dt at the end of it, whether you chose to write it out as the function or as f of t. Okay? Has to be ended with a dt. But after that, it's a calculator problem. I can grab my calculator, math 9, right? Math 9, type that in. It did say rounding to the nearest whole number, and then you guys will have to help me because you got the calculators here. This is a lot. 2,474. And with every problem that we are doing, we are going to put the label on it, whether it tells me to or not. So 2,474 cars. Questions on that? Good so far? Okay. Part B. Is the traffic flow, which is this function right here, is this function increasing or decreasing? And so if we think about, and this is a very watered down visual of this, but this function is some sort of trig equation, which remember can oscillate. And they're asking us, is it increasing or is it decreasing? And the thing that helps us with that would be if I were to look at like time equals 7, wherever that is, and what is the slope of the tangent line, or what is the derivative at that time? The derivative being positive or negative tells us whether that function is increasing or decreasing at that time. And so what we need to do is find f prime of 7, right? And again, we have a calculator. So what I'm going to do is write down what it is I'm finding in my calculator, but I don't actually have to do the derivative of that function. We could. That is definitely one we could do the derivative of. But grab your calculators. Derivative is math 8, right? And we're doing it specifically at t equals 7. And what does that come out to? I think it was negative. Okay, so if our derivative is negative, that means the slope of the tangent line is headed downhill right there. Our function is decreasing. And so to answer the question, I would then say decreasing the derivative at time equals 7 is negative. A little redundant there since we just said the derivative is negative here, but indicating that I know that that's what it's telling me. I would always put that. Okay. Any questions? On the last two parts, I kind of highlighted some things for us because these are phrases that we see all the time, but they sound so similar because they both use the word average, and getting those two straightened out. What is the average value of a function compared to what is the average rate of change, right? Your average value, you guys have a function, you have a formula, and we need to make sure that we remember the formula. For average value, your formula is 1 over the difference in the integral, b minus a, times the integral a from a to b of your function, whatever that is, right? So in this particular instance, the average value of our traffic flow, the average value of this function from 10 to 15 is 1 over 15 minus 10, and again, I'm getting that from the interval, times the integral from 10 to 15 of f of t dt. And again, we have to have the dt on there to set up a correct integral. And that's, again, just grabbing my calculator, 1/5 times math 9. I want to say it came out to 80 something something. 80. Okay, and then the label part of it. And we have specifics here, so we will label every one of our numbers. Remember what these things are. The integral itself gave us the number of cars, right? And the 10 and the 15 are done in time, yes? Which is seconds, no, minutes. And it's dividing by that, because we're 1/5, or dividing by 5. So it would be in cars per minute. See where I'm getting that label from? Okay, and then compare that to our average rate of change. Our average rate of change formula. Anytime we're doing an average rate of change, remember that it is the function, whatever your function is, we'll call it x, and just a reminder here. So x of b minus x of a over b minus a. Average rate of change is a fancy word for slope, right? It is the slope between those 2 points on that function, or the slope of the secant line. So going up to our function, that would be f of 15 minus f of 10 over 15 minus 10. And again, I grab my calculator and I figure out f of 15 and f of 10, and we're going to divide that answer by 5. And then we're going to label it. And the label part, we haven't talked about an average rate of change label in a while, but remember what our labels would be, and it comes from the original fraction, right? The f function's label is, oh, it's not on this page, cars per minute, right? So this is cars per minute, right? Cars per minute, or cars per minute squared. Okay, let's go through our scoring guide, see how we did on these problems now that we talked through this. And again, some of this is a little bit of speculation. I have not graded this, and actually it's a little bit different per year. As I read a lot of these things, is that sometimes priorities change. But the first one was very eye-opening to me. To me, on the first one, I could have just grabbed my calculator, typed it in, and got an answer. But if you look at the scoring guide off to the side, if I had just written down 2,474 cars, which is the answer, how many points would we have gotten out of 3? 1. You would have gotten 1. You would have gotten only 33% of that correct, even though you did the problem correctly. That's kind of eye-opening, right? So the whole limits and integrand thing, limits would be that you correctly got the interval here from 0 to 30. Okay, that you then correctly set up an integral, and you could have put the function here, or just f of t since it's already defined, and then that we have an answer. Notice it does not mention our label on this one, so we would put it just to be safe, but they did not give us a point for having it or not having it. All right, part B. Now they have a lot written up here, but the point is kind of a twofold, and remember, you don't get partial points. So it says 1 point for the answer with reason, which means if either part of that is not correct, no point, right? Incorrect answers will negate a correct answer. So their answer was decreasing. That's what we said, wasn't it? And we said decreasing because, and they kind of put it both ways that we did, that the derivative was less than 0, or specifically that it was negative 1.872. Now, I don't know the difference if you would have to put both, and I've read the scoring guides on this, and they make no indication as to if you have to put both. I think one would be sufficient. I do want to point out one thing. Does it bother anyone that they have it both as 7.2 and 7.3 up there? And I keep hounding on. One thing I've learned that is crazy, and I don't want to like necessarily encourage it, but AP will allow you to truncate a number instead of round, which means you just stop writing numbers after the third spot instead of rounding after the third spot, which would both be acceptable. I personally would not risk that. I would always just round like we know how to round. Okay. All right. Part C is worth 3 points again. It says 1 for the limits, 1 for the integrand, and 1 for the answer, just like we saw at the beginning. So again, I did this on my calculator. If I get to 81.899, 1 point. You have to show the setup. So continuing to show that we know how to communicate what is happening in the problem with our mathematical notations. Part D was 1 answer, 1 point, and that is just for the answer. Now, I've seen this question before where it was 2 points, and it is completely on what's going on around it and where they need to distribute the points. Sometimes you get a point for the quotient, and sometimes you don't. So I would always show that if it's an average rate of change problem. They didn't give a point for it in this one. However, if you total all this, that is actually only 8 points. The last point on this particular problem came from this little caveat at the end, and that is that you got 1 point for correctly labeling C and D. So if you forgot a label on one of those, you did a wrong label on one of those, no point. So that's why we're going to label everything. We had labels on other numbers earlier that apparently they don't care about, part A. They only cared about C and D on this one. But again, not something that we're going to risk. Nor did they ever ask us for a label, did they? But they did put a point on it. So showing our setup, labeling our answers. And then another thing is you don't get that point if you don't answer one of these. So let's say I don't know how to set up. We've talked about this a long time ago. I don't know how to set up an average rate of change problem. I panic, I forget. But I know what the label would be. Can I just write down a number and label it? 100%. 100% because I would get this point right here for having a correct label. It is not tied to having a correct value. Okay. Any questions for me? All right. We are going to do